Hey everyone, today we're going to talk about hyperbolas that are centered specifically at HK, so somewhere not at the origin. If you'll see up top here, just to refresh from yesterday, we've got our two equations for a hyperbola centered at the origin. The top one is when we have the horizontal transverse axis, and the bottom one is when we have a vertical transverse axis. So we're going to keep that same format. The only thing is we're going to be moving the center. So you'll see here what's happening is that the numerators change for our equation, but the setup is still the same. So let me show you how we're going to go about doing that. Let's look at this first example here. I've got the x minus 2 squared over 16 minus y minus 3 squared over 9 is 1. I know that that has a horizontal transverse axis because the x part is positive. So first thing I want to do is find my center. My center here is going to be at 2, 3. Right, I get that from here and from here. It says x minus 2, so the x coordinate is positive 2. And this is y minus 3, so the y coordinate is positive 3. Okay. I also know that a squared is 16, which means that a is plus or minus 4. And I also know that b squared is 9, so b is plus or minus 3. And so that is going to help me to generate the graph of the hyperbola. So we'll start with our center. We're at 2, 3. And now from there, just like we did yesterday, we're going to create that box, which is going to help us to draw in our asymptotes and then to sketch our hyperbola. Our horizontal axis is the transverse axis. So along the horizontal, we're going to go 4, 2, 3, from that center. So I'm going to go 4 in this direction and 4 in this direction. And from the center, I'm going to go 3 up and 3 down. And that's going to help me create my box. So there's my box. I'm going to go ahead and put in my asymptotes. Oops, that wasn't very straight, but you get the idea there. Okay, those are my asymptotes, and then from there I can sketch in my graph. It's horizontal, so I know that I'm, or my transverse axis is horizontal, so I know my graph is going to be over here and over here. Oops, over here, like so. So it really isn't much different than what we were doing yesterday. It's just that we have a different starting point. Let's go ahead and try another one. In this one, we see that the vertical or the transverse axis is going to be vertical because our y value here is what's positive. So we still have our a value, or this is our a squared value and this is our b squared value. But let's start with our center. And here's where you just have to be careful. It's easy to make a careless mistake here. Remember, the x coordinate comes first in your center, so make sure you write it correctly. It's going to be -2, 1 as our center. Okay, I've got a squared is 25, so a is going to be plus or minus 5. B squared is 4, so b is going to be plus or minus 2. And so my center is at -2, 1. So my center is here. Remember, my transverse axis is vertical, so I'm going to go 5 in the vertical direction. So 5 up and 5 down for my center. 2, 3, 4, 5. And I'm going to go 2 to the left and right of my center to create my box. Okay, again, you can go ahead and put in your asymptotes there. Oops. And again, this is just, generally like a rough sketch of what it would look like. We don't have to actually plot any specific points. Okay, so that would be when you have a vertical transverse axis. Okay, let's talk about actually finding the asymptotes or find the equations of the asymptotes. We know how to do it graphically, we know how to sketch them in, but let's actually talk about finding that equation. If my center here is at HK, so let's say HK is here, this would be a horizontal transverse axis, right? So I would end up going over this distance, right? This distance would be my A, and this distance here would be my B, right? If I were to then have my box. And I'm not using any numbers here because I'm just trying to sort of demonstrate what's going on. So the slope of this line, the slope of this particular asymptote, right, rise over run. So my slope is B over A, just like it was, we talked about that yesterday. But now I'm not centered at the origin, so now I have to actually use point slope form to find the equation of that asymptote. If you don't remember point slope form, we have y minus y1 is equal to m times x minus x1. We have a point that's on the line because the center of that box is a point on our line. So we actually are going to use the center of the hyperbola as our point. So it's just going to be y minus k. Our slope, remember, is going to be b over a. But remember, we'll have two asymptotes here. So we'll have one with a positive slope and one with a negative slope. So I'm going to go ahead and put the plus minus in there. Times x minus h. So this is the general form for the equation of the asymptotes of a hyperbola that has a horizontal transverse axis. Okay? The only thing that changes when you are looking at a hyperbola with a vertical transverse axis is that slope. Instead of b over a, that slope becomes a over b. Okay? So over here, the only difference would be that slope. So let's go through actually a couple of examples here of how we would do that. This is write the equations of the asymptotes for the following hyperbolas. Well, first thing I want to do here is identify which type it is. I know it's a horizontal transverse axis hyperbola. I also know that my center is going to be at -3, 0. I know my a squared is 25, so my a is going to be 5, right? Technically plus or minus 5. And my b squared is 16, so I know that b is going to be plus or minus 4. And so I can really just generate the equation of the hyperbola from my formula. It's just going to be y minus 0 is equal to plus or minus 4/5 because it's b over a for my slope for this one, times x minus 3. And so you just clean that up. That would just be y is equal to plus or minus 4/5 times x minus 3. And that's the equation of both of my asymptotes for that particular hyperbola. If we look at this example 1b, this is a hyperbola with a vertical transverse axis, so be careful when you're labeling your center. Remember, your center is going to be at 1, -2, that's the x coordinate. Your a squared value is 36, so you know that a is going to be 6, and you know that b is going to be 7, and I can put the plus or minus in there. And so remember, because it's a vertical transverse axis, your slope is going to be a over b this time, right? Because a is what's going up and down. So when you write your equation, you've got y plus 2 is equal to plus or minus 6/7 x minus 1. And that is the equation of both of your asymptotes. You don't need to distribute and then move that to. You can leave it in point slope form. The only reason I cleaned this up was just because it was y minus 0, so I just rewrote it as y. But that's all you have to do to write the equations of your asymptotes. Okay, so we know how to graph the asymptotes. We also know how to write the equations of the asymptotes. So let's go through an example here. In this example, we're in general form. We have to actually put this into standard form, so we're going to have to complete the square. So I've got 4x squared plus 8x minus 9y squared minus 18y, and then we're going to move that 6 over, or that negative 6 over becomes positive 6. I can factor the 4 out here, so I have 4 times x squared plus 2x. Take half of that middle term, so half of 2 is 1, square it, and I get 1. Over here I can factor out the 9, or the negative 9 rather, so I end up with y squared plus 2y. And then when I complete the square, I'm going to add 1. Remember on the other side here, and I'm kind of running out of room, so I'm going to write it below. I've got the 6, but then remember I have to add 4, because 4 times 1 is 4, and then I have to subtract the 9, because negative 9 times 1 is negative 9. Okay. And so in this case, I end up with 4 times x plus 1 squared minus 9 times, hold on, erase that, 9 times y plus 1 squared is equal to 1. So now what am I going to do with this 4 and this 9? It does look a little bit different than what we're used to seeing, right? Because normally there's a number over here that we can divide through by so that we end up with 1 on the right. We already have 1 on the right. So this one's a little bit tricky. It's just a unique type of a problem. I'm going to show you how to get to the end with this. It won't always be like this, but if you see something like this, you'll know how to approach it. What I'm actually going to do is I'm going to rewrite this a different way. Multiplying by 4 is the exact same thing as dividing by 1/4. And multiplying by 9 is the exact same thing as dividing by 1/9, right? If I divide by 1/4, you change it to multiplication and you flip the fraction. So it's the same as multiplying by 4. And so if that's the equation that I have, well, I know that my center is going to be at -1, -1. I know that my a squared is 1/4, which means that a is plus or minus 1/2. I know that b squared is 1/9, so b is plus or minus 1/3. I know that this is a horizontal transverse axis hyperbola, so I know then that the slope is going to be b over a. Okay, so the slope of my asymptotes is going to be b over a, so that would be 1/3 over 1/2, which is the same as 1/3 times 2, so that slope is going to be 2/3. Pardon me. So the equations of my asymptotes is just going to be y plus 1 is equal to plus or minus 2/3 x plus 1. That would be the equations of my asymptotes. My center here, I'm going to do this quick because I'm about to run out of time. My center is at -1, -1. Okay, my box here is really, really small because it would be 1/2, 1/2, 1/3, 1/3. So this would be my box. There would be my lines. You can go ahead and graph those lines. Start at 1, 1, up 2 over 3 would be my slope there, and 2 over 3 here, this would be my slope here. It's a horizontal one, so you know it's going to fit right in here, kind of like this, And I'm squeezing that in real quick. I'm about to run out of time, but that's how you would go ahead and approach that one. Okay, folks, we'll catch you next time. Thanks.